So let's go to the combustion of gaseous fuels. Bali, in combustion, it will be three basically. The one that we have discussed last meeting was combustion in general. Now we'll focus on gaseous fuels. So let's proceed. For gaseous fuels, what are the sources? You know naman that typically we have the natural gases and methane, di ba? Kasi if the gases become heavier, yung mga if it's not methane, ano na kunyari mga butane na siya, nagiging liquid na siya. Although it's very volatile. So these are typically found in nature. And then we also have some di ba, made from solid fuels, so derived from coal, biomass, and waste. May mga iba na ginagasify. So those are the fuels. Also from petroleum distillates, the liquefied petroleum gas, refinery gas, and oil gasification. So mga gasified siya. Kasi you'll notice, di ba ito mga gas siya. And then from here, mga liquid na siya. Tapos ito, bitumen, alam ko maraming solid na to. And then as it goes down, it's more viscous. And of course, it's gonna be hotter. So again, the types are natural gas, liquefied petroleum gas, yung LPG that we have. Ito hanggang butane. Yun, sorry. Hanggang butane dito. After butane pala, liquid na siya talaga. And then producer gas, this one consists of, eto guys, please take note of this kasi di ba, you know naman in concepts, it might come out. Consists of CO, H2, 55% of N2, etc. And you have water gas consisting of CO, H2, and small amounts of N2. Obtained similar to a producer gas but blown with steam. Kaya bumababa yung M2. Whereas here, naka-specify siya roughly 55%. You know naman, di ba, what makes gases or the other fuels valuable is its heating value. So heating value, it's released when fuel initially is at 25 degrees, reacts completely with oxygen, and the products are returned to 25. So typically, heating value is reported at 25 degrees. So it's taken as the negative of the standard enthalpy of combustion of fuel, so heat of combustion. So there are two types of heating values. The higher heating value, or sometimes known as the gross heating value or gross calorific value, also known as the total heating value when water comes out as liquid in combustion reaction. So higher heating kasi malaki pa yung value niya, whereas at the lower heating value, ang ginagawa, the heat that is needed to vaporize the liquid, kinakalculate natin. Now, what if i-convert natin yan, liquid na yan, into vapor? So that means the heating value nabawasan. Kaya, if I ask you which one is higher, it's always the gross calorific value or the higher heating value. And then, of course, di ba parang, alam mo naman, di ba, gross sales at saka net sales, laging mas malaki yung gross. So in here, lower heating value is, of course, lower. Bakit? Sa lower, vapor na siya. So these are the two formulas. So ito yung mga standard enthalpies of combustion. Saan siya ginagamit? For example, calculate the higher heating and lower heating value of the following fuels. Ayan. Nakalista na siya. So, in here, basically, you will just be using the table. I'll show you lang. For example, guys, higher heating and lower heating value of methane gas. So, the fuel is methane plus oxygen because it's combustion. Even if nilagay nyo dito with nitrogen kasi di ba combusting it with air. What will be used is only oxygen, right? Yung nitrogen, mapupunta lang sa final products. Pero in the reaction, only oxygen gets involved, producing CO2 and H2O. We don't care about the carbon monoxide kasi hindi naman siya sa complete combustion. So in here, the higher or the gross calorific value is, when you look at the table, CH4 is negative 890.36. Ayan. So the negative of the heating value is 890.36. Wala nang problema. Now, according to the formula for lower heating value, the higher is equal to the lower plus the number of moles of water that is produced per mole of fuel multiplied by the heat, di ba? Yung enthalpy of evaporation. So, edi 890.36. And then, when you look at this, at the equation, for every 2 moles produced of water, kasi diba 1 mole yung basis natin, for every 2 moles produced ng water, meron tayong isang fuel. So 1:2 lang siya. So 1:2. And then, what's the heat of vaporization of water? Ayun. Heat of vaporization of water is 44.013 kilojoules per mole. Kulang ng H to. So, all in all, you'll notice 802 this one's 890. So, you lost the difference due to evaporating that much liquid water into gas na ginamit mo yung energy. Okay, let's go back to this. Sample of natural gas. So if the basis is 100 moles of natural gas, so for example, in this case, look at the natural gas composition. The composition is 90% by mole, CH4, and so on. So what I did was I placed the number of moles in here. The total is 100. What are the heats of combustion? If in case, guys, diba, we will be giving this. Hindi naman namin papa-memorize. So the heats of combustion tables, we will be giving them to you in case. So it's just filling out the table. And then, ito, number of moles times heat of combustion. Diba, it's easy lang, oh. 90 times this one is this. Tapos, number of moles of H2. Diba, how many H2 here? Dalawang H2. Kasi isang H4 siya. So, 2 times 90 is 180. Ilang H2 ito? Diba? 3 H2s. So, ito, 2 H2. 3 na H2. Ito, 4 H2. 5 H2. Walang H2. Walang H2 kasi CO2 and N2 siya. So ito, 2 times 90 is 180, 3 times 5 is 15, 4 times 2.5 is 10, 5 times 1 is 5. You understand this? Okay. And then, what's the molecular weight of the component? It's 16, 30, and so on. So here, you just need to multiply this one and this one. Okay, you have that. Paano ba yung average molecular weight? Di ba ang average molecular weight is the total molecular weight divided by how many moles is the total, yung natural gas natin? This one. So now that we know that, gross calorific value is just the summation of the delta H's, which is this one, divided by the number of moles. E dito na. Tapos ang net calorific value again is gross calorific minus the vaporization of water. Eh ilang water ba siya? So ilan ang H mo? 210 yung H2. So for every 1 H2, may isang H2O. So 210 for every 100 moles times 44.013. So what I would like you to know of, kasi in the test, you have to know the formulas and this one. Pero typically, sa concepts ko ilalabas to kung may solving. Konting-konti, if ever. So here, I won't go into solving this. I'll skip this. I'll just give it to you here. What I'll focus more on are cases 1, 2, and 3. Lagi, guys, in exams, wherever you are, whatever school you study at, when you deal with combustion, you will always encounter 3 cases in each type of fuel. Case 1 will always be given the complete analysis of the fuel. Lagi. Ang case number 2, all the time, flue gas analysis. So baliktad. What you will be given in case number 2 is the analysis of the product side. So ang case 1, reactants, which is yung fuel. Case number 2, all the time, product side, flue gas. And then there's what you call case 3, partial analysis of the flue gas. So ibig sabihin yan, hindi namin ibibigay lahat. If you fill in the blanks ninyo. Magbibigay kami ng konting analysis ng reactant, konting analysis ng flue gas, and then if you fill in the blanks. So if you ask, which one is the most difficult among the 3? Case 3 is the most difficult type ng case. The easiest is, of course, case 1. Why? Because we're so used to solving things from given, di ba? Or from feed to products. Kasi that's the direction that we're more used to doing. Okay. So typically, as I have said in case number 1, ano yung mga given sa atin? Apart from the analysis of the fuel, typically, theoretical oxygen, di ba? Pero ito, hindi na ako magbibigay ng calorific values. Yun yung sinasabi kong hindi ko na isasali sa case 1, 2, and 3, yung mga calorific values so that it will not be difficult. If percent excess or fractional conversions are given, the following can be calculated again. Number of moles of oxygen fed, di ba, is theoretical na needed natin. And then, 1 plus the amount of excess. Kunyari, sabi natin, ang theoretical ko, 30. Ang excess ko, 30 din, percent. And what's 30% of 30? 9. So ang total number of moles of air fed is 39. Right? And then what's the number of moles of nitrogen fed? You can solve that. What's the number of moles of air fed? You can solve that. Products of combustion, so using the reactions for complete and incomplete combustions of, we've had this, CO2, CO, and SO2. Alam na natin na number of moles of water in the flue gas is the number of moles produced from combustion, number of moles from air, kasi air can sometimes contain moisture, and number of moles from the fuel. Kasi sometimes yung what if may moisture content yung fuel mo. So even this one. So the number of moles produced plus moisture plus the fuel. Ang oxygen naman, you know that na there might be what you call excess oxygen. So yung excess oxygen yan, paano ba natin makukuha kung ano yung excess? All the time, di ba, you know naman, this is fed minus used. So, excess na siya. Kasi, ang percent excess, guys, again, it's always based on complete reaction or 100% conversion para makapag-solve tayo ng excess. Kaya lang, sometimes even if we feed, kunyari ang theoretical natin, for example, 100 moles, ang excess mo 50%. So that means ang total oxygen na fed is 150 moles. Pero kahit na ganun karami, sometimes what if yung system mo, it's not as efficient as you would want it to be? Para ang efficiency niya, not all reacted. Only 90% reacted. So that means if that happens, hindi yung lahat ng 100 moles of your oxygen will be used. Even if nag-provide ka ng additional 50 moles, what if 90 moles lang yung nagamit, di ba? So the fed minus you. So ang sumobra, instead na just 50, 60 moles yung excess. So in here, finally, of course, the excess plus N2 for remaining combustibles. And then the nitrogen, of course, it's nitrogen from air. And again, sometimes may nitrogen din present in the fuel. So let's just try this. Pure ethane is burned completely with 20% excess air. Air is supplied at 25 degrees Celsius, 740 torr or mmHg, and is substantially dry. Calculate the following. Analysis or dry basis of the products of combustion. Kilogram of dry air per kilogram of fuel gas. Cubic meters of air per kilogram of ethane. So, eto iba-iba, di ba? Parang, hala, ano to? Kilograms, biglang nagkaroon ng cubic meters of stack gases at 400 and 1,000 kilopascal, and partial pressure of water in the products of combustion. So in this case, guys, you will notice there are differences in temperature, right? So kung may mga differences in temperature na, baka kailangan natin gamitin yung combined gas law. So before we solve, this is review of combined gas law. Diba, you know naman na PV is equal to nRT is your ideal gas law. So if I want to solve for the R, I'll have P, say, for A na lang. N, A. Ayan. P, V, N, T. Right? So, combined gas law natin, instead of PVT lang, pwede natin isama yung N doon kasi what if yung number of moles is not the same? So, if R is equal to R, I can say that P V over number of moles of A T is equal to dito at STP. Guys, when I say STP, what's the conditions at STP? Temperature has to be in 273 Kelvin and 1 atm. So in here, that's gonna be ang pressure ko 1 atm, and then volume, di ba ang volume at STP is 22.4 liters. You should know this. Over number of mole for 1 mole of ideal gas. 1 mole. And then, what's the temperature? 273 Kelvin. So, ganito siya. Kasi sometimes I'll ask you, what is the volume of the gas formed? E di alam natin that volume would be number of moles of A. Tapos, when you look at the volume, 22.4 times 1 atm divided by PA. Tapos, kumbaga pinagsasama-sama ko guys, number of moles kasi, number of moles per 1 mole, volume, dito ko nilagay kasi volume yung unknown. Last is temperature. Temperature A over 273 Kelvin. So, most likely, in order to solve for that, nakaganto. Pagka ang pinapasolve ko naman temperature, edi ang i-isolate mo yung kabilang side. Okay. So now let's go to the actual problem. Again, let's go back. It says in the problem, burn 20% excess air. It's ethane, C2H6. Air is supplied at 25 degrees Celsius, 740 torr. You're asked to solve for the product gases, which comes out at 100 kPa and 400 degrees Celsius. Okay. So you have the burner. You have the fuel. You have the products, and you have the air. So air, the products of combustion, and fuel. All right. The fuel that we were given is C2H6. The air was given 20% in excess. It comes in at 25 degrees Celsius and 760 torr. The product comes out at 400 degrees Celsius and 100 kilopascal. Okay. So ating natin part and given. And then basis. Wala namang binigay sa ating basis eh. So let's look at the per kilogram of fuel. Diba? Tapos dry basis of combustion per kilogram of ethane. So it's up to us. Pwede naman tayong mag-basis ng 1 kilogram of fuel. Pero if I just say ganito, if I want 1 kilogram mole of fuel as a basis, 1 kilogram mole of ethane, what's 24 plus 6? It's 30. So that means 30 kilograms of fuel ang meron ako. C2H6. All right, let's go to the reactions. C2H6 plus oxygen gives me carbon dioxide plus water vapor. Again, what am I solving now? Kasi di ba you're given 20% excess air. Bakit kilogram mole? Para 1 mole na lang to. Wala na tayong problema. Bakit kilograms ang ginamit ko? Ba't hindi grams? Kasi later on, in the questions, per kilogram of fuel, per kilogram. So, para mas madali, na ito, 1 kilogram mole is 30 kilograms of fuel. So, let's balance. This is 2, 6 to, so we need 3. Ang oxygen ko, 4 plus 3 is 7. 7 halves. So, I change and then final. Again, initially, if you have 1, 0, 0. Diba? So, we solve for the TiO2. Theoretical oxygen is basically, how do we solve this? For every 1 mole of C2H6, na given, 1 kilogram mole, 1 C2H6 in every 7/2 of oxygen. How much is this, guys? That's, sorry, 3.5 kilomoles of oxygen. Pero, is that what is fed? No, that's the theoretical that I need. You can see on top that you were fed 20% in excess. So, I can solve for O2 fed. How do you solve for O2 fed? Basically, 3.5 kilomoles of O2, 1 plus 0.2. What's 1.2 times 3.5, guys? Calculate for me, please. That is 4.2 kilomoles O2 fed. E di alam na natin yung amount of oxygen being fed. What is the amount of nitrogen being fed? Para makuha natin finally yung air. E di ito, madali lang naman ng nitrogen. That's 4.2 kilomoles of O2. For every 21, there's 79 nitrogen. So this one would be 4.2 times 79 divided by 21. That is 15.8 kilomoles of N2. So now that we know this one, so yung 4.2 na gagamit ko sa taas. Okay, we'll do the reaction. So in here, wala namang sinabi kung ilang percent conversion siya, di ba? It did not say na only 90% of it reacted. So we will assume all of it has reacted. Tas wala namang sinabing na 90% formed carbon dioxide, only 10% formed carbon monoxide, wala. So our assumption is that it's full, complete combustion. So for every one of this one, there should be 3.5 moles of this. And then 2 ang mafo-form nito, 3 ang mafo-form nito. This is again plus and plus. So all in all, you'll have 0, 0.7, 2, and 3. So what's being asked in letter A? Analysis of the products of combustion. So that means in letter A, the ORSAT analysis. Ano ulit ang ORSAT analysis, guys? What should be the components of the ORSAT analysis? Di ba we had that the other time? It's a dry basis. Wala dapat yung water. So that means wala namang matitira kasing C2H6 sa product gas, edi okay na. So you will have CO2, O2, and N2 in your analysis. The CO2 that you will have is 2 kilomoles. Diba? The O2 that you have is 0.7. The N2, ayun, nasa ibaba, 15.8. All in all, in here, 16. Ito, 16.5 plus 2 is 18.5 kilomoles of gas. And in here, we need it as, ano guys, we need this as percentage. Can you give it to me as percentage? What's the first one? 10.81. The next would be, please, 3.78. And the last is 85.41, giving us 100% composition. So, it doesn't really matter, guys, even if it's kilomoles. Kaya naman natin i-convert eh. Letter B, kilograms of dry air per kilogram of fuel gas. Guys, dito papasok yung tinuro ko. So, kilograms of dry air per kilogram of fuel. Kilogram pa lang. Okay. Dito papasok later. Kasi ito volume na. Meron tayong cubic meters eh. So, kilogram of dry air. First, ilan ba yung dry air natin? Ayun no. Dry air consists of 4.2 kilomole O2 plus 15.8 kilomole N2. Pero hindi pa to kilograms, kilomole to. Take note that for every 1 kilomole of air, 29 kilograms siya, di ba? Yun yung molar mass divided by per kilogram of fuel. Isn't it that 30 kilograms yung fuel natin? Can you please calculate this for me? 4.2 plus 15.8 multiplied by 29 divided by 30. 19.33 kilogram of dry air per kilogram of fuel. Letter C. Ang sabi dito, cubic meter of air per kilogram of ethane. Sorry. Of air per kilogram of C2H6. Okay. Alam natin yung, hindi natin alam yung cubic meters of air, but we know the total number of moles of air. Ilan yung total number of moles of air, guys? 4.2 plus 15.8. This is the kilomoles of air. Di ba ang nilagay ko dito, guys? Look. Number of moles for every 1 mole. 22.4 liters. Di ba? And 1 atmosphere, etc. Okay? To. So, ito pala, para maalala nyo. Molar volume of any gas at STP. Alam na natin yung 22.4 liters per mole. Diba? In quiz number 1. It's also 22.4 cubic meters per kilo mole. It's also 359 cubic feet per mole. So ito, alamin niyo lang to ha. So that means in here, kilomole siya, we can use for every 1 kilomole, kasi di ba we have Na over 1, 22.4 liters or 22.4 cubic meters. So we can use 22.4 cubic meters per kilomole. So magka-cancel. Now, ano yung katabi niya? For every 1 atmosphere, di ba? and pass P, the given A. So for every 1 ATM, ano ba yung given sa atin? Kilopascal. Yung given sa atin air, di ba? The air 760 torr. Let's convert this. Guys, can you convert this? Di ba this one is 1 ATM? Ang gusto natin, this one, paki-convert. What's this? The answer here? Paki-convert sa ATM. 760 torr ba? 740 torr. Sorry. May mali ako. Guys, can you please convert this to atmosphere for me? Ilan siya? How many ATM is this? 740 divided by 760 is what? 0. Convert this to atmosphere, yung 100 kilopascal. This is 0.987 ATM. Guys, what's being asked in here in letter C? Cubic meters of air. Saan ba yung air? Di ba ini-introduce yung air? At what conditions? 25 Celsius and 740 torr. So, ito, dapat dito yung 0.974 ATM. Okay na tayo dyan. And then lastly, temperature A per 273. So, nasa ilalim yung ideal condition na 273. It comes in at 25. So that means 273 plus 25 yung nasa taas. Over kilogram of ethane. So you know that you have 30 kilograms of C2H6. Can you please calculate the top for me? So that's 4.2 plus 15.8 times 22.4 divided by 0.974 times divided by. So here, please check if it's correct. I had 502.09 0.0797 per 30 kilograms of ethane. So dividing it by 30, I have 16.74, tama ba? 16.74 cubic meters of air per kilogram of ethane. So that means yun yung sinusupply sa atin. It's this one. Na 19.33. Okay. Next. Cubic meters of stacked gases naman, guys. Stacked gases. Letter D. Cubic meters of stacked gases per kilogram of ethane. Kilogram of C2H6. Take note that the stacked gases exits at 400 degrees Celsius and 0.987 atmosphere. Okay. So in here, cubic meters ng stacked gases. Alam ba natin ilang moles yung stacked gas? Alam natin, ayun no, 18.5, di ba? Tama ba? Yung stacked gases. 18.5, yun nga lang, wala pang water to. Right? So total number of moles of stacked gases is 0.7 Lagay ko dito. O2, CO2, H2O. O2, CO2, N2, H2O. This one, yung oxygen natin, it was solved already. 2 plus 3, baliktad. CO2. 2 plus 0.7 plus 15.8. Ito yung na-solve natin in front, di ba? In front, we had this as 18.5 already. Kilomoles. Pero kasi di ba stock analysis yun na ORSAT? Hindi natin sinama yung water vapor. Water vapor that we have is 3. So 18.5 plus 3 is ilan? 21.5 kilomoles of all stock gases. E di meron na akong moles of stock gas. Right? 21.5 kilomoles of stock gases. Let's go back to the relationship. Okay. 1 kilomole sa ibaba. I need 22.4 or basically the relationship. 22.4 cubic meters per kilomole. And then pressure. For every 1 atm, ilan ba yung i-correct natin siya into what? 0.987 atm. And then, yung ideal temperature ang nasa bottom. 273 Kelvin sa top 400. So, 273. Edi ngayon, on top, cubic meters na lang yung natitira natin. At the bottom, 30 kilograms of ethane. Can you please calculate this for me? Yung top muna. So, yung final answer mo is 40,096, tama? So, on top, 1202.88 cubic meters of stock gas. Per this one is cubic meters of stock gas per kilograms of ethane. So, this is your final answer. Ang mahirap dito, guys, is yung reactions kasi madali na eh. Ganito lang. Ang mahirap dito, guys, is this. Please take note of the relationships. Saan nanggagaling to? PAVA and ATA. Tapos ito, yung PAVA and ATA equivalent niya in STP. Tapos typically ang sinusolve naman natin volume. So ang pinagsama ko yung number of moles. Pinagsama ko ito, di ba? Number of moles. Ito volume. Ito pressure. Ito temperature. Kaya lang, iba-iba ng placement yung ideal kasi it's a combined gas law, di ba? Lastly, letter E. Partial pressure of water in the products of combustion. Partial pressure ng water, di ba? Partial pressure of water is basically total pressure, di ba? Paano masolve yung mole fraction? Let's just say X H2O is equal to mole fraction of water. Paano masolve yung mole fraction of water? Basically, moles of water divided by total number of moles, total pressure. So we can solve this. Total number of moles of water produced is 3. Total number of moles of all the gases is 21. Tama ba? 21.5. Para lang alam ninyo yung blue na star. Times total pressure. Di ba? Partial pressure kasi of water in the products of combustion. In the products of combustion, they come out at 100 kPa. So, 100 kPa is, again, 0.987 atm. So, this is 7 atm. Can you please calculate this for me? Ilan siya? 0.1377 atm. Paki-convert nga to into mmHg. Yung partial pressure. Hindi naman sinabi kung express as what eh. Nakalagay ba in mmHg? Wala naman. Pwedeng yan or ilang mmHg guys? Multiply that by 760. This is 104.65 mmHg. Yung partial pressure of water. So, either one of them is correct. So, yun siya. Okay. So, again, let's go back for you to understand better. Given lang tayo ng fuel, C2H6, being burned at 20% excess air, the air enters at 25 degrees Celsius and 740 torr. So I converted it to atmosphere para it's easier for me to calculate later on. The products of combustion come out at 400 degrees Celsius and 100 kPa. So that's 0.987. So when you look at the problems in here, most of the problems are in kilograms of fuel gas. So some of you might ask, sir, is it possible for me to use 100 kilograms of fuel? It's okay. Kaya lang, pag 100 kilograms ang fuel mo, you have to remember that this one, the reaction happens in number of moles. Iko-convert mo siya to moles. Whereas ang ginawa ko, nag 1 kilogram mole na lang ako ng fuel, which is equivalent to 30 kilograms of ethane. So, para dito, madali na 1 na lang ang gagamitin ko. So, using the reaction, 1, ang problema, hindi natin alam ano yung ilalagay nating oxygen. So, what I did was, I solved for the TiO2. The TiO2 that's needed to react with 1 mole or 1 kilomole of this one is 3.5 kilomoles of O2. It was stated on top that it's 20% in excess. So 3.5 kilomoles times 1 plus 0.2, dahil 20% excess, that's 4.2. I place a star. That star, the one I used here. Sige, lagyan ko na rin ng star dito para alam nyo. The green star. Okay, so how do we calculate for the number of moles of nitrogen fed? The based from the air, the oxygen fed, I calculated that, this one. So if I ask you, what's the air fed? The air fed is equal to 4.2 plus 15.8, di ba? Yan yung air fed natin. So, Orsat analysis, it's easy. Ito plus the nitrogen kasi hindi pwedeng gamitin yung water vapor. Kilograms of dry air. And yung kilograms of dry air is this one, 4.2 plus 15.8, yun na yun. Multiplied by the molar mass per kilogram. Okay na. So in here, cubic meters naman. gagamitin natin ulit dito. Again, yung 22.4, these ones, to, tsaka ito, yung tatlong yan, they are the standard conditions. Di ba? 22.4, 1 atmosphere, and 273. Yung mga standard conditions. So, ang ini-input natin, Na, Pa, at saka Ta. So, you can easily get that. Pero ito, air kasi to. So, you look at the air side. In letter D, stack gas. So, you look at the conditions of your stack gases. Kaya yan. Okay?